Yo, what's up, guys? Daniel here with another video. I'm just gonna get straight into it. What I'm gonna be to doing today is I'm going to be studying the STD vector, and I don't know how long it's gonna take me, but I want to. I don't want to say I want to master this container from the STD class, but or STD library, but I really wanna understand the ins and outs of it. So if you're watching this, you'll probably just see me study this page and just continuously try to code this vector and test it and try and understand all the methods of the STD vector class. So yeah, man. So I think I'm just gonna go ahead and take off where I left off, and I'm just gonna remove all these pages. I've been interacting with vectors. I mean, in the last video, what I did in the last video was what I did the last time, really. So I don't even know where to begin. I have a very big I have a very big repository, C plus plus Python repository. I doubt I'll be going back to C though, or at least not this year or next year. But right now I want to do C plus plus, and I'm just trying to make sure that my microphone is placed properly. All right, so I'm using Firefox because I just don't. I'm trying to be lenient on my processor. It's not even about that RAM. I have tons of RAM. My issue is my processor at this point, because I'm recording at my OBS studio settings are just off. I think. I don't even know where to begin. I feel like my STD class, my C plus plus directory is full, to say the least. I feel like it's complicated, and there's no way of me trying to sort it out. I don't even know how I'm gonna even begin to sort it out. I don't even know where to begin. I'll just write vector2.cpp, Control Shift S, and I'll just probably just redo everything that I did in the other page, and also more from what I learned from the internet. So I'm just gonna name it vector2.cpp. Oops. It's just gonna rename that vector2.cpp, and then over here, okay, I'm gonna say g++ vector2 dot c wait vector dot cpp. All right, so we don't have anything. I forgot how do we even include, guys? C++, say hashtag include open brackets iOS stream, etc. Okay. All right. So if I remember correctly, it's int main. Nearly did some C++, some JavaScript stuff there. Return 0, and then let's just try and print out something. std cout hello world. Okay, let's just do that. I need to keep looking at my keyboard whenever I type in colons, because not yet from, oh no, brackets, or like what are these things, arrows, because I'm not yet familiar with this keyboard. So I'm just gonna try and rerun that, and then I'm gonna say a.out. I'm working on Ubuntu, so there we have it. It runs. Go into that right there. It's crazy how am I not doing this properly? I can't find. Does that work? Oh, I didn't compile. Okay, no, it works anyway. I mean, this was the way to do it either way. So I think I need to include vector, and then vectors. What I realized is that it's a capacitor will double whenever inside element. So this is how we instantiate it, or not instantiate, declare. This is how we declare. I remember in the last video, or the last time I worked with C++, I learned what the difference is between instantiate, declaration, instantiation, and what else? And all the other ones. Oh my goodness, man, I forgot how to code. Dude, I forgot how to code, man. I haven't really focused on coding in such a long time, but I'll get my groove back. It's just what happens when you take a long break from coding. So I know once I get back to my groove, I'll be unstoppable. Okay, define and header vector template class. Okay, I'm yet to understand what exactly these things mean. Well, I think I once had an idea. Okay, I did have an idea, and generics and all that stuff. I understood completely, but now I don't. It's crazy. STD vector is a sequence container that encapsulates dynamic size arrays. STD PM vector is an alias template that uses polymorphic allocator. What is an alias, first of all? Hey, listen, guys. I'm just gonna act dumb on these videos until I just figure my stuff out, okay? So if you see me and you see that, oh, Romeo, like you're not even familiar with the basics of C++. Yes, I'm not familiar with the basics of C++, okay? I took a freaking 1 year hiatus from C++, so of course I forgot everything. Well, not everything, but you get what I mean. Also, an alias is used to indicate that a named person is also known or more familiar under another specific name. Oh, I get it. So is a rap name an alias to other people? The elements are stored contiguously, which means the elements can be accessed not only through iterators, but also using offsets to regular pointers to elements. This means that a pointer to an element of a vector may be passed to any function that expects a pointer to an element of an array. The storage of the vector is handled automatically, being expanded as needed. Vectors usually occupy more space than static arrays because more memory is allocated to handle further growth. This way, a vector does not need to reallocate each time an element is inserted, but only when additional memory is exhausted. The total number of allocated memory can be queried using capacity. Okay, so we can just check the capacity. If I remember correctly, in STD vector, I remember studying this back in the day. I know that you get, like, when you declare a vector, a certain amount of RAM storage is allocated for that specific vector, and then when you keep adding elements inside that vector and then you surpass the threshold, it'll allocate even more memory. It'll just give you, let's say you store 10 items and then you get to item 9 and then you automatically get to item, or you insert elements and you get to element 10, so you basically filled up that vector when you fill up the vector, more space will then be allocated. Maybe they'll give you another 20, or like space enough for 20 or 10 other elements that you can insert. So it does this automatically, if I remember correctly. And I think so because the total amount of allocated memory can be queried using capacity function. Extra memory can be returned to the system via a call to shrink to fit. So I think this is where, okay, let me just read here. Reallocations are usually costly operations in terms of performance. The reserve function can be used to eliminate reallocations. Oh, so I can use I feel like I'm gonna want to write some of these things down. I don't know if I should write them on a piece of paper. I think I should not write them on a piece of paper. I think I should write them digitally, since I'm here digitally with you guys, and then I'll just transfer it to my piece of paper at a later stage. Um, Trying to see if you guys can still hear me. Okay, I hope you guys can hear me properly. Okay, cool. So, reallocations are usually costly operations in terms of performance. The reserve function can be used to eliminate reallocations if the number of elements is known beforehand. So, that means that if I know that my vector will probably not have more than say 50 elements inside, I can reserve enough space for just 50 elements in my vector, and then it wouldn't be costly for me if I just kept on adding elements inside the vector, and then at a later stage wanted to use shrink to fit. But I want to understand exactly what shrink to fit does. Request the removal of unused capacity. So basically, what we do in C, in the programming language C, when you have in C, you have to manage everything yourself. Like, if you create an array and you allocate enough, let's say an integer, and you allocate enough space for maybe 10 integers, and you at a later stage wanted to remove that added or allocated memory, you want to get rid of it. Because if you don't get rid of it, it's called, geez, I forgot, but yeah, if you don't get rid of it, I mean, you would have to, if you want to get rid of it, you need to do it manually. So you need to go through, I think, each memory address and actually delete it, if I remember correctly, or free it. I don't remember quite vividly, but yeah, I'm starting to have an idea. It is a non-binding request to reduce capacity to size. So this is the shrink to fit. It is a non-binding request. What does non-binding mean? Okay, no, it's fine. It is a non-binding request to reduce capacity to size. It depends on the implementation whether the request is fulfilled. If reallocation occurs, all iterators, including the past and the end iterator, and all references to the elements are invalidated. If no reallocation takes place, no iterators or references are invalidated. I'm not quite understanding what all this stuff means. If reallocation occurs, all iterators, including including the past, the end iterator, and all references to the elements are invalidated. If no reallocation takes place, no iterators or references are invalidated. Um, at most linear, linear complexity at the most. Guys, I haven't studied my complexities, right? So I need to start doing that. Term complexities. I need to study that. I need to study all that stuff here on the on YouTube. I'm gonna study it by myself first, and then I'm gonna try and teach it over to you guys. Complexity at most linear in the size of the container. Notes: if an exception is thrown other than by T's move constructor, there are no effects. I don't know what that means yet. And also, guys, one thing I realized about programming over the years is that you shouldn't force yourself to immediately understand what is going on, especially when you're reading documentation. Especially if you're a beginner. If you're a beginner and you're reading documentation, usually what you're going to do is that you're going to find yourself seemingly always, if you try and look through documentation, you're not going to understand a single thing until you actually go watch maybe a YouTube video or tutorial somewhere, and then you try and implement it, and then at a later stage you try and go back and read the documentation. Then you have much better understanding of exactly what you're doing and what you're reading. So usually when I read stuff like this, if an exception is thrown other than by T's move constructor, there are no effects. I don't understand exactly what that is. I know what an exception is, and I know what it means that an exception is thrown, but all this stuff by the T's move constructor, there are no effects. I don't understand. So if I don't understand, I just read it and I just continue and try and pick up whatever it is that I can understand. And at a later stage, I know that when I do come back, or if I do come back and read this page again, I will 100% have an understanding of exactly what this is. So now, since I've restarted learning C++, at this point in time, I don't understand, but I will. I will at a later stage, and I will tell you guys that I do understand when the time comes. Just thought I should let you know, guys. So this is what we did already. We have a function main. This is the declaration, std vector of the type int. Let's try and do that. Std vector of the type integer. What do we just name it vec, right? Oops. Std cout default constructor capacity is defaulted constructed capacity is this, and then we say v dot capacity. I named it vec. The allocated capacity of the vector is, and oops, std we're gonna construct that. We're gonna try and run that. The allocated capacity is 0. Interesting. And then if we say resize, and if I remember correctly, these are things that I need to like write down and actually study. What does the resize do? Where am I? This is shrink to fit. Okay. If we resize, capacity of 100. So resize is, let me just do this. All std vector methods, because maybe it's in here. Oh, here they are. Template parameters, guys. Templates, not generics. In C++ they're called templates, but in other programming languages they're called generics. Right, I'm just gonna get rid of that because I just basically opened another page. that is just just this page. Just open it again. I opened it again. I hope you guys can hear me because I slur some of my words. I can't speak properly. I apologize. Okay. I'm more interested in all of the methods and trying to know what all of the methods do. Um, yeah. The standard library provides a specification of a city vector for the type bool, which may be optimized for space efficiency. Uh, Vector bool space efficient dynamic bit set. I need another coffee. All read only operations, never swap, SD swap. What are these? Iterator and validations. Specifications. I feel like I need someone to help me understand how to read C++ documentation. How to read C++ documentation. How to read C++ docu. I feel like if someone has a YouTube video explaining how to read this website, I will have a much better understanding of C++ as time goes on. Oh, here they are. Oh, here it is. Here it is. Someone actually has a video on this, and I am going to watch it. Oh, can I download it? I didn't know I could download it. Oh, this is just one video. So I'm gonna download that, and I'm gonna I want someone to I'm gonna study that video. If he actually explains, then I'll be able to read this much easily and actually explain what's going on. But yeah, member type. Okay. As a matter of fact, I really should know how to read C++ documentation if I'm going to be learning a lot of C++ this week or this month or indefinitely. All right, cool. So I just wanted these member functions actually. So okay, they have constructor. Okay, I want the methods. Aren't these used when you're dealing with um, iterators? But let me check real quick. So we have a Vic, we have IT. We're not using that. We have Vic2, yeah. IT2, okay. Vic2 dot begin dot end. So these are actual methods. These are no iterators. Returns an iterator to the beginning. So what does an iterator return? Does it return the memory address, if I remember correctly? I think so. And then here we what is this thing called when you put an asterisk in front of the actual element? I know that you're trying to print it out, but you're not, like, what you get is not the what you get from all of this stuff. Or like if you just see out I, you'll get the memory address. So now you need to, I forgot what what it's called. Let me just go to pointers. Yeah, I forgot what the name of all that operation is called, but you put an asterisk in front of the element, and then you're trying to basically print out not the memory address but the actual element itself, whatever you stored in that memory address. So yeah, okay. I do remember our begin and our end. Let's see, our begin returns a reverse iterator to the beginning. This is crazy. That's why C++ is so big, and like you can't master this programming language because they have so much stuff for everything. Um, Very different from the V programming language. But I just fear that as time goes on, the V programming language, especially if it gets enough steam, it'll also just end up being one of those programming languages that are just very big to very big, very difficult to learn. Hopefully that's not the case because I really like that programming language anyway. Capacity checks whether the container is empty. Okay, so this returns either true or false. The size returns the number of elements, right? Max size returns the maximum possible number of elements. Maximum possible number of elements. So isn't that basically capacity? Returns the number of elements that can be held in currently allocated storage. So isn't max size probably just gonna give me like a very big number, or like isn't max size just gonna return a very big number depending on maybe my storage or my RAM size? I don't know. It's only one way to find out, guys. So, but these are what I was looking for these methods so that I can practice some of them and see what I do get. So the allocated capacity of the vector is 0. So I'm gonna try and get the size, and then should probably have copied that. The size of the vector is, and vec dot size let's see if that works. Oops. I need a shortcut to go to the terminal. So the size is 0, of course. Now I wanna, you see how they used, let me see, something flying. Resize. If I remember correctly, resize just gives, I don't know if resize allocates like just 100, or like it just allocates 100 values to the vector, but they're all 0. If I remember, I'm just gonna say v dot resize 100. V dot resize. I'm just gonna say 10, and then let's see what the size is. So the size is now 10 because now I resized to 10, but then now returns the number of elements that can be held in the current allocated storage. Alright, can I just get v dot, okay, std, the max size of the vector after allocating storage is, after resizing. Is a max size, yeah. It's like every time, ever since I learned how to use std and line, I've just been using that over and over again. Right. So as I predicted, like the maximum size is just incredibly big, incredibly. Just want to see if the number changes after I compile it again. It doesn't change exactly. 951. Can I just do this instead? Just want to see. Of course, the number should change. Oh no, it shouldn't. Okay, so max size is just absolutely incredibly, like you need it when you're really doing intensive tasks that are memory intensive. But in the era that we live in now, you probably will not run out of vector size. But yeah, okay. So now I know I have 10 elements inside that vector. Now what I want to do is reserve storage. I want to click on this so bad, but reserve. This is shrink to fit. Okay, let me go to reserve. Like, I'm so excited. I want to learn so much about these methods, like the reserve method, and I'm very excited. I'm like a kid in a candy store. So the reserve method, increase the capacity of the vector. Can you guys see? Hope you guys can see. Increase the capacity of the vector, total number of elements that the vector can hold without requiring reallocation. Increase the capacity of the vector to a value that's greater or equal to the new cap. If new cap is greater than the current capacity, it's like, what's the capacity? Now you need to really understand what the like how much it can hold. Okay, so let me just yeah, how much it's capable of holding, the capacity, like what's the maximum volume this cup can hold. So probably 400 milliliters. The maximum amount that something can contain. Yeah, okay. So I was here. No, what is this? Shrink to fit. Should probably put you here. Guys, my PC just froze. Dude, no way. No freaking way. My PC is not freezing on me, bro. Probably removing it from the charger is not a good idea. Was not a good idea, because now you're just making the PC want to use less power to save energy. Okay, so yeah, my Firefox literally just froze. So this is not the website that I was on. C++ reference. I was shrink to fit. Capacity returns the number of elements that can be held in currently allocated storage. Oh, the number of elements that can be returned. Okay. The reserve storage. So I was here. Should have did this. No. Yes. If new cap is greater than the current capacity, new storage is allocated, otherwise the function does nothing. Reserve does not change the size of the vector. Because what is size? Why am I confused? I know that, guys, come on. Capacity is the total, return the total number of elements that can be stored in that vector, right? At first it's zero. If you just declare and do nothing, it's zero. If you resize to 10, then the the size is also zero when you just declare. If you resize, the vector the vector's size is now 10. If you resize it to 10, because how many elements are in the array, right? Max size is like something completely different, just tells you how much the vector is capable of containing. So the capacity, I resized it to 10. I wonder what the capacity is, because I'm not so sure that it's 10, because you find that, because I know, like I said, vector will keep on adding or allocating memory or space for the vector so that you can keep inserting elements inside of it, and whenever you reach a certain threshold, it'll increase the capacity of it. I feel like I remember. So I'll just check what the capacity is right now after resizing. The allocated capacity of the vector is 10. The size of the vector is 10. Okay, so the capacity is not okay. Okay, let me just do this, because I just need to completely understand what capacity does. Capacity returns the number of elements that the container has currently allocated space for. Capacity of the currently allocated storage, it's constant. This shows you how the capacity function works and how the growth works. So if the size is 1, the capacity will be 1. Size is 2, capacity will be 2, 3. It goes up. What are these things called when it goes up by 2, 4, 8, 16, 32, 64? The number of bytes, right? So if I if I now I think I have an understanding. If I keep adding elements, like add an element, like one element at a time, like add one element, there's there's one element in the vector. If I add another one, the two elements in the vector, the capacity remains at 2. If I add a third element to the vector, the capacity will now jump to 4. It will not go to 3. Geometric sequence. It's called the geometric sequence. So can I just research why computers use geometric sequence? Is it because of storage? Okay, I'm just gonna skip this, but it uses the geometric sequence to keep allocating memory. So, and I mean, just like storage or anything else computer wise, that's just how it works. So if there are 3 elements, the capacity will now go to 4. If there are 5 elements, it'll, sorry, if there are now 4 elements, if I add another element and I have 4 elements in the vector, the capacity will remain 4. And then if I add the 5th one, it'll move from 4 to 8. If I add a 6th, 7th, 8th, nothing will happen. But if I add a 9th, it'll move from 8 to 16. So on and so forth. But if I resize to 10, then it's 10. If I add 10 elements, well, the size, no, not the size, this will give me the total number of elements in the array, of which right now is 10, since I have 10 elements in the array. But the capacity, when the number of elements is 10, will be 10 unless I add another one now. It'll jump to not 8, obviously, but 16. So I can prove that now. Let me add more elements to the vector and check the capacity. It should jump, to 16. Because now I know that, yeah, so let me just add an element to the vector. So how do I do that? How do I add, is it pushback? How do I add an element to the vector? I think it's vec.pushback. Okay, so let me say vec.pushback. Let me just add 200 as a number, and then we're just gonna get the capacity of it again. This one, I'm gonna put you here, buddy. Whoa, why is it 20? Does it double now? Interesting. Let me just resize it to 2 and then add one more element, and see if it'll jump to 4. And it does jump to 4. Okay, well, this is a bad example because like the double of 2 is 4 either way. So perhaps add 4 and then add one more element, should go to 8. Well, let me add one more because the double of 4 is 8 anyway. So let me wait. I'm so confused, dude. I mean, this is not even important because I understand how capacity works. I feel like I'm just trying to go deeper in it and try and understand exactly how the sequences work because I know double of 2 is 4, double of 4 is 8, double of 8 is 16. However, I was just surprised that when the elements were 10, they were 10, the size of the vector was 10, and I added one more element. I thought it was just going to go directly to 16. It was going to resize itself. Not resize, but the capacity will now be allocated to 16, but then it turns out that it doubled, so it's fine. I think I should just write notes here and then I'll be on the way. This is crazy. I probably took about an hour just trying to understand how capacity of vectors work. Let me just try and see. Goodness me, dude. I think I want to go make a cup of coffee. I'll be back. All right, guys. Where were we? All right. Okay, cool. So the capacity. I'm not in my right state of mind because I took such a long break. um, but I'm glad to be back. I should just check if I have everything set up for this video. Okay. All right. Perfect. So I was playing music. All right. Capacity. Got it. Just I think I needed to check the shrink to fit. So we have reserve. I think I should write my notes here because we have reserve, we have resize. How do I do this on a new keyboard? Okay, there we go. Methods. Reserve vec.reserve vec.resize will resize the vector to whatever size you insert. So vector will now have as many elements as you want, as you have the value to be. And then vector capacity checks how many items can fit in the vector. Vec.size will gives number of how many elements are inside the vector. Yeah, I mean, I guess you could get vec.size, which will give you the number of elements inside the vector. And then also, I hope you guys can hear me properly. And also the, okay. And also the, and then you say vec.capacity, which will give you the capacity of the vector. And then if you minus the size from the capacity, that'll let you know how many elements you can still add to the vector, without it resizing again. And then reserve. Reserve and shrink to fit. If the vector changes capacity, all of them. If not, none. Oh, wait, what? Let me just go to the reserve. The erases elements and all elements after them. Okay, interesting. Okay, this is the reserve method. Increase the capacity of the vector, total number of elements that the vector can hold without requiring reallocation. Increases the capacity of the vector to a value that's greater or equal to the new cap. Reserve. So wait, what is resize? Maybe I'm confused. If the vector changes capacity, all of them. If not, let me just do this. I'm starting to get confused between what reserve and resize. Resize is the container to contain count elements. Does nothing if count equals size. If current size is greater than count, the container is reduced to its first count elements. Okay, so if I have an array or a vector that has 10 elements, and then I call resize, and I resize maybe to 8 elements, it won't resize to 8 elements, it will stick to 10 elements. Or if I have an array, a vector that has 10 elements, but the capacity is equals to, does that change the capacity or what? Resizes the container to contain the count elements. Does nothing if count equals size. But what does it change exactly? Resize. So if the size is, because the size is the number of elements that are inside the vector. If a vector has 10 elements, then the size will be 10. So here, resize the container to contain count elements. Does nothing if count equals size. If the current size is greater than count, the container is reduced to its first count. Okay, which is 10 elements in our scenario. If the current size is less than count, for example, if my count is 15, but then my size is 10, additional default inserted elements are appended, sorry, not apprehended, what am I saying? Additional copies of value are appended. Copies of what value? Which value in this case? Value, the value to initialize the new elements with. Resize, size type, count, size type. Okay, and the value. So I think I understand. Resize. This is, what is, I'm confused. Is that not reserve? That's resize. What is reserve? Reserve is increase the capacity of the vector, the total number of elements that the vector can hold without requiring reallocation. Increase the capacity of the vector to a value that's greater or equal to the new cap. If new cap is greater than the current capacity, so this is deal with capacity. Reserve, let me just say reserve. deals with regarding capacity. Regarding capacity. Um, if new cap is greater than the current capacity, new storage is allocated. If new cap is greater than capacity, new storage is allocated. So it just increases the capacity. That's it. It just increases the capacity. Guys, you guys have no idea how excited I am to start coding again. You're like, I'm extremely excited. This is, I've been longing to get back to my coding days, so I'm very happy that I can actually sit here and actually write code and just talk to you guys. So yeah. Okay, so the reserve method, just changes the capacity basically. Reserve just changes the capacity. I should probably put this a little bit higher up. Doing a little bit of cleaning of code, although I really shouldn't, because this entire repository is just messed up. Just gonna commit. Alright. So now I understand the resize. Resize the vector whenever the size is inserted. So a vector will now have as many elements as have the value to, wait, we'll resize the vector to whatever, spelling doesn't matter, whatever size you insert. So vector will now have as many elements as you have the value to be. So, but I just want to understand, that's reserve, this is resize. Oh, if the current size is greater than count, then the container will be reduced to its first count element. So if I have 10 elements in, if I have a size of 10 in a vector, but then I reduce the, I call resize and I say resize to 5, then the new vector will now have, or the vector will now have 5 elements inside of it, or the size of it will be 5. I wonder what the capacity will be. I think the capacity will just remain the same, unless in such a situation, if this such a situation were to happen, I would probably need to oh wow, that wouldn't work. I thought I would maybe call this reserve, but reserve only reserves memory. It doesn't remove excess memory. Makes sense. I wonder if I'll like remember these things. As long as I keep practicing every day, then I should. I see no reason why I shouldn't. Okay, erase elements and all elements after them. Erase. Let me just do this because I kind of understand, not kind of, I actually do understand what those do. So this is reserve. This is this is erase. Iterator, erase. I feel like I'm missing something. Is it here? Reserve. I am. Can I just get the this is reserve. I want resize. This is resize. Okay, so if I increase the size, I need to pass in a value that I will initialize the new elements with. Yes. Resize. And if we want right. My coffee is very, very strong. I don't usually drink coffee that's this strong. But I'll have it. I'll have it. Um, Insert. Never heard of this. If the vector changed capacity, let's just open this. Insert. Oh, insert at a certain position and the value of it. Okay. Now this is very interesting. Iterator position and then the value. Iterator. So do I need to use iterators in order to insert? Insert elements at the specific location in the container. Inserts value before the position, just before the position. Or if it's element 0, 1, 2, 3, and I want to insert it at position 3, then 3 will move to 4, and then the new value will be placed on item 3. I think everything else will be just pushed to the side. Or I'm lying. No, I don't think I'm lying. I think that's exactly what's going to happen. Inserts value before the position. Inserts count before the position. Okay. Inserts count copies of the value before the position. So however many numbers that you want to add. Inserts elements from range first, last, before position. This is crazy, dude. This overload has some effects as overload 3 if input it is an integral type. This overload participates in overload resolution only if it okay, I don't understand what this is. I'm just gonna skip all that stuff. Skip through the complexity as well. This is a print, this is the main, this is the vector, C1, print 1, C1. Wait, what? What is this? Don't even know what that is. So you need, let me just insert nc plus vector. I think vector insert function in C++ is used to insert elements into the vector container. The different ways we use it are to insert single values into a vector, to insert the same value multiple times, or to insert another vector. I'm gonna have that here, vec dot insert. Is it insert, right? Yes. To add single value into vector. Oh. Or to insert another vector. Interesting. Like if a vector is of the type int, how would you insert another vector inside the vector? That is very interesting. Introduction. In this tutorial we're going to learn about insert boom 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 boom. This count initial vector for auto I equals vector begin I dot. Interesting. Vector insert vec dot begin. We're inserting vector dot the first parameter. Oh, okay, pos and value. So vec dot begin should be the first item, right? Oh, this is the position. What is the position? Vec dot begin. Insert at this position. Vec dot begin, which is the first position. Add the value 10. So we're gonna add 10, and then the rest of the vector will be normal. So add. So I'm just gonna say little task add the number 10 to print the first array and the altered array. So I'm going to create a vector std vector. I'm going to wait, in this case do I make it an integer vector? Oh yes, int. Wait, I think I made a mistake here. Just trying to realize to insert another vector. Okay, it's fine. Because I was trying to understand if maybe I made a mistake when I said this, and maybe I interpreted the wrong way, because in this case I'm thinking, so you can insert another vector. I can use this insert method to insert another a different vector inside this particular vector. Now I'm just wondering how they inserted another vector inside a normal vector like this that is of the type int, because that wouldn't make sense. But then I'm realizing now that they didn't do that. They're just inserting a value from another vector, or they're just using another value to extract. They're using another vector to extract an element and insert it into this new vector, or insert it into the same vector, right? Um, with the dot begin method. But then now I'm realizing that maybe that is still the case, and they can still use vector dot insert, the method, to insert values or elements from, or no, to insert a whole vector into this vector using insert. Um, Now I'm realizing that that could be a possibility, since I haven't scrolled down yet on this page. And they probably, no, there's a multiple, insert another vector, like I said. So we're going to go through everything, because I really want to understand how that works. They probably didn't use the vector int, or actually they did. We'll see. STD vector integer, we'll name you vec1. We just declare, and then now we want to instantiate you a little bit. Yep. I wish I could instantiate you by giving you default values, like maybe 1 to 10 or something. I want to see how they did it here. Okay, they just gave you random figures, initialized it with random figures, and I could have just done that at the top, but I'll just vec1 is equals to these elements. So I'm just gonna say 1, 2, 3, and 4, and then I'm just gonna name this is declaration, this is initialization. And then what I'm gonna do now is I'm gonna insert. So I'm gonna say vec1 dot insert. I'm gonna insert which position. So I want to insert from the first position, which is vec1 dot begin. This returns the actual index number, right, which will be 0 as far as I remember, and then the actual value, which is 100, and then that should add. So I'm gonna print the vector. And how do I print the vector? For auto I equals to vector begin. This is okay. I is smaller than vector dot end, and increment I, and then this operation. Yeah, okay, let's do that. For auto equals vec1 dot begin, vec1 smaller than vec1. No, I made a mistake. I'm gonna say for auto I didn't declare my index variable. I smaller than vec1 dot end, which is the end of the vector, and then we're gonna increment, and then we're gonna say we want to print it out, std cout value of vec1 is pointer vec1. No, sorry, what am I doing? Like that. 100, 1, 2, 3, and 4. There we go. I don't know why I wrote that. Really shouldn't have. I just do that just to keep records of whatever it is that I'm typing. Just so that I can save everything and not lose anything in the process of me trying to write these things and learn. So insert 100, insert this is the value, so this is the position. 3 times, this is multiple times. Right, I don't need this stuff, guys. Like, some of these things are unnecessary. I just want to skip to inserting another vector inside my vector. That's the one that I'm more interested in. Insert another vector inside another vector inside my vector using insert another vector inside my vector using the insert method. So further, we can also insert elements of another vector to our old vector. We just need to pass the iterator pointing to the position in our vector, where we need to insert another vector along with that, the operator pointing to the starting and the end of the second vector. Further, we can insert elements into another vector to our old vector. We just need to pass an iterator pointing to the position in our vector, where we need to insert another vector along with that, the iterator pointing to the starting and the end of the second vector. Let us make a small example to understand the working. So we have 2 vectors that are declared. Initial first vector, which is basically printing out the first vector. We print out the second vector. Insert vector 2 at the beginning of vector. Vec, which is this first vector. Vector insert. Vector begin. So we're not really inserting another vector here, guys. But I understand what they mean. What they're saying is that obviously these are vectors of the type int. So of course, C++, you cannot insert something of a different type inside maybe a vector or another container that is of another type. That doesn't make sense. If you have a vector of integers, then you need to insert integers into that vector. There's no other way. So what they mean here is that when you have a vector of elements, say integers in this case, 2, 4, 6, 8, and you want to insert 1, 3, 5, and 7, or this entire vector, you cannot insert the actual vector. You need to insert they're basically saying that if you want to insert the elements of the second vector inside your own vector, this is how you would do it. So obviously the parameters would be similarly the position that you want to insert the vector to, the number of elements that you want to insert, and how many elements you want to insert. I think that's the second position, or like the second parameter, or in this case it was the second parameter right here, which were 3 of 100. So 100, that will occur 3 times at the which position? The end of the actual vector. So what this means is that now I just want to try and understand what's going on here. So This is the position, so we want to insert it at the beginning of the vector. We want to insert vec2 dot begin, which is this, all the way till vec2 dot end. So in this case, you're not really specifying, or in this case, you're giving you're giving this insert method. You're not giving the insert method the position, the number of items that you want to duplicate into the vector, 3, the actual value that you want to insert. No. In this case, if you pass in the position, I think if the compiler determines that you are passing in a pointer, when this an iterator, right? A pointer pointing to the first, or pointing to whatever position. In this case, it's another vector, but it's a particular position. Then it changes. This insert method is not the same method that we were speaking about. Because remember, okay, before I continue, it's not the same vector that we were speaking of. Not vector. What am I saying? Oh my goodness. Can I just restart that? Because I'm trying to insert all this information into my head. So in this case, since this method is different from this method, although it's the same thing, you use insert, and in C++ things work like that because you can, what is it called when you rewrite another method? What is it? It's overloading, operator overloading, right? It's not, no, it's not. What is it called when you write the same function multiple times in C++? Or same method, not, guys. Okay, yes, overloading functions. It is overloading, but it's not overloading operations, because overloading operations is operations are your equals, smaller than, greater than, minus and plus. But then when you're overloading functions, what that means is that you're basically rewriting the same function, but it does different things depending on what the user passes to it. If the user passes in, let's say, one more parameter, then it does this. If a user passes 3 parameters, then the function will do this. If the function, etc., etc. So that's what's so confusing about this damn C++, because it's very difficult to grasp. You need to keep a journal in your head about what goes where, or what happens when you do this and what happens when you do that. So that's why you always need to reference C++, man. Crazy. So I think for me to just go to where I want to go to, I think I should just the insert. Where is it? This is distant. So the insert. So here they are. These are, I think, all the methods. We have insert, where it's the position and the value. We have insert, where it's the iterator position. The count and the value. We have another one where it's iterator position, the size, the count, and the value. This is wild. This is crazy. There's no. How do you even master C++ when so many containers, where you have so many containers? How do you master C++ when you have so many methods in each container that do different things? How do you master C++ when you have different methods, or almost all the methods are overloaded, right? So you have one function, which is the insert, which is a method in this class, but the same method has been written 5 times. So now you need to keep an idea of, if I use two parameters, the first one is I'm passing in the position, the second parameter I'm passing in the actual value. But if I actually use three parameters, the first one, everything changes. The first one is the iterator position, second one is the count, and then the third one is the value. This is crazy, but I guess we live and learn. And I think people use C++, or like they learn C++, whatever you know in C++, you just use it as is. You don't need to learn everything. As long as you can solve whatever problem that you have, then just do it. The problem is now when you try and write very efficient code, and code that is very easy to understand for everyone, and etc. So it's fine. I'll just learn whatever I feel like I can and should learn, and as long as I'm able to solve problems. And then if I need to learn other things, I will just continue on and just keep learning more methods until I can solve whatever problem I have. Insert another vector inside my vector using this method. I wanna actually implement that. I'm just gonna go to, because I wanna really understand what exactly is happening over here. Insert vec2 at the beginning of the vector. Vec insert vec dot begin. Oh, this remains position. I just wanna go here. Const int iterator. I'm just gonna retype that. Const iterator position and input it. Is that it? Or am I using something else? It's definitely not this, because that's the size type. It's not this. So I don't think it's this. It's not this as well. Yes, I think this is it. The iterator position. I think this is what's this thing called? The iterator. First, iterator last. So this is vec2 dot first, vec2 dot last, vec2 dot begin, vec2 dot end. As far as I understand, the second and the third parameters that are being passed in. Yes. So we're passing in on my initial vector the position where I want to insert at, and then we call in whatever second vector, the start and the last elements of memory addresses of that actual vector. So So I'm gonna say std vector. I'm gonna make it integer. Vec a. I'm gonna give it 1, 2, 3, 4, 5. And then similarly, I'm gonna say vec b. 10, 20, 30, like that. And then now I'm gonna work on inserting vector b into a. So what do? I loop, right? For auto j equals to vec a dot big. No. Am I doing the right things, dude? No, I don't need to do this. I'll do this when I want to print. So what I want to do here is vec a dot insert. I want to insert where at my position. So I want to insert it at the first position. So which is vec a dot begin. I want to insert vector b from its first position, which is vec b dot begin, and I want to insert the vec b from the beginning to the last element. So I'll say vec b dot end. And then what I'll do now is I want to print. To see if the elements in vec b were inserted at the beginning. So now I'll print. So I'll say for j equals 0, so for just instantiated and give it a type. We'll give it an automatic type. Auto j is equals to vec a dot begin. J is smaller than vec a dot end. J plus plus. And what we'll do here is we'll say std cout, and then we'll say pointer j. Is it j? Yes. Std end line, and we should have something that works, I think. Try to commit there. vec2.cpp and 10, 20, 30, 1, 2, 3, and 4, 5. There we go, guys. Git add, git commit, added a second vector inside another primary vector using iterators and the insert method. I can imagine the insert method is very important in competitive programming. I mean, it should be. Doesn't make sense why it wouldn't be very important. Wow. Okay. This is crazy. Okay, what I want to do now is I think I should just let this vector learning journey take a pause. I think I understand vectors enough now, actually. Just did a couple methods, pushed back, looped through, inserted into other vectors, inserted values into other vectors. I just don't know how to delete vectors or delete a value. It's probably, I know pop back will probably remove, yeah, removes the last element, erases elements. So I guess this you just pass in, it takes maybe probably one parameter and then you just remove that one parameter. I'm sure it has a lot, it's been overloaded a lot where you probably remove multiple elements and stuff like that. Of course, to remove the position, iterator, remove the position, okay, erase the first or from this position to the last position given what iterators you pass in. Same thing. Yeah, so I guess it's just position first last. Okay, I get it. um Let me just see something. I think I should just leave, guys. I'm obviously going to continue studying vectors, and I'll see you guys in the next episode. Peace.